Crowcon, gas detection you can trust, providing innovative gas detection solutions for over 40 years. Crowcon is relied on around the world to keep its customers safe. This is the operator training video for the GASTEC Mark V, the latest flame ionization detector or FID gas leak detector from Crowcon. It builds on industry-proven FID technology from the previous GASTEC generations by adding a clear and simple user interface with GPS and data logging. Joe has been called out to investigate a suspected street-level gas leak. GASTEC is an FID-based detector, so provides the sensitivity and fast response that Joe needs to track a suspect leak quickly. GASTEC is housed in a ruggedized carry case, containing everything needed for the job in hand. It is easy to attach the shoulder strap. This can be adjusted so the unit sits neatly at waist height. The detection probe is assembled, the inline filter being attached to the end of the probe hose nearest the GASTEC and connected to the unit. The GASTEC is switched on, and after following a simple startup routine, the hydrogen gas is turned on and ignited. The FID detectors are electromechanical devices and therefore require some time to warm up and stabilize. It is best practice to give the GASTEC 5 minutes to reach operating temperature before starting to detect leaks. Now Joe is off looking for a gas leak. Let's have a quick look at the startup procedure he has just gone through to get to this point. After turning his GASTEC on using the power button, the instrument goes through its startup sequence before displaying the main menu. Pressing the power button key again cycles through the available backlight levels. The icons on the main menu enable Joe to quickly check battery charge, data log storage, hydrogen cylinder pressure, FID status, GPS lock, and service status. The hydrogen cylinder pressure and FID status icons are currently flashing, indicating the hydrogen gas is turned off and the FID is not lit. At this stage he can use the setup menu to adjust the display backlight timer and contrast for the environment that he is working in to his own user preferences. These adjustments need to be made prior to starting up GASTEC and turning on the hydrogen gas. The context-sensitive soft keys and prompt-driven operation system provide clear access to the menus so he can easily control and configure his GASTEC. Joe now presses start, turns on the hydrogen gas, and after a 30-second stabilization period, presses the igniter to light the FID and start his GASTEC. If he can't remember the exact sequence, it's no problem, as GASTEC leads him through a whole process, using a series of on-screen prompts. Joe checks that he has hydrogen gas pressure and GASTEC is lit by checking the status icons are no longer flashing and confirms whether or not he is in clean air. Before setting off, he zeroes the instrument in the info menu. As he wishes to produce a position log of where he is looking for leaks before setting off, he checks the GPS is displaying lock. He now knows the GPS positional data will be recorded along with the time, date and the gas reading. Joe now starts looking for the leak. The tick-tick of the Geiger counter-like audible tone indicates no gas present. A sudden change in audible tone from the tick-tick to a high-pitched continuous tone tells Joe he has found a leak. As the GASTEC ppm reading is showing over range, he can switch GASTEC to a higher ppm range in the info menu and get a reading of the gas concentration. As Joe moves nearer to the leak, he uses the info menu again to switch the display format to the graphical mode so he can clearly see where the peak reading occurs. As he's using the GPS positional data logging, Joe decides to use the mark feature to tag the peak reading in the data log. Data logging allows analysis of the leak survey back at the depot using mapping software such as Google Earth. Transferring the log file to a PC is easily accomplished using GasTec's inbuilt USB connection. More details of this feature are available in the GasTec user manual. GasTec needs to be kept reasonably level during gas detection to maintain accuracy. If tilted, an audible and scream alarm warns the operator that the limits have been exceeded. The alarm is cleared by simply returning the GasTec to a level position. If Joe finds he can't hear the audible tone anymore as traffic noise from the nearby road is drowning it out, he can increase the volume of the audible tone in the info menu. He can also use GasTec's optional headphones by simply plugging them into the connection panel on the underside of the instrument. Having identified and recorded the leak, Joe prepares to leave. It is important to shut down GasTec and to turn off the hydrogen gas supply. If the hydrogen is not turned off, hydrogen will continue to flow, presenting a potentially serious safety risk. This is done by pressing stop and following a simple set of prompted instructions before finally turning GasTec off. GasTec is easy to maintain and is supported by a complete range of optional accessories including different probe types. Details can be found in the GasTec accessory catalogue. When GasTec's batteries need recharging, the power LED will show red. A multi-region charger comes with the unit, while an optional car charger accessory allows the GasTec to be charged on the road. The LED flashes green whilst the unit is charging. When the hydrogen gas pressure is low, a new cylinder is easily inserted. The screw connector to GasTec's pressure regulator is turned anti-clockwise to disconnect the cylinder and clockwise to reconnect. Finally, everything is repacked into the case. Job done, Joe can return to the depot. As we have shown, the GasTec Mark V is easier and more flexible to use than earlier models. The simplicity enables any user to reliably detect leaks. Crowcon, gas detection you can trust.